Good morning, ladies and gentlemen. Welcome to our session. The name of our session is Application of NTUST Solar Glass in Paraguay. The session advisor is Professor Jinghua Yang. The TA is Joromo. In this session, we will introduce you a very high capacity of solar glass developed from National Taiwan University of Science and Technology. The solar glass, it can transfer the sun energy to become electricity for the application of power inside the building, such as lighting power and the cooling power. Because the glass, it can transfer the sun heat to become electricity. So at the same time, it can also do a very good insulation for the building. So inside the building, it can save a lot of cooling load. So the power not only supply the energy of the building, it can also charge the electricity car. So we strongly recommend this kind of glass could widely apply in Paraguay. It can supply a lot of energy for your country. Why the glass can generate a lot of solar power? Because we set up a semiconductor inside the glass, and we also set up a very good insulation function inside the glass. For example, when we apply on the gallery, compared with the current glass, it can save 75 electricity. Good morning, everyone. Team 1 are students from UPTP. They will do the test of solar glass applied on skylight and the window in Paraguay.
Hello everyone and welcome to our forum. Today, my classmates and I will discuss our research on the topic of renewable energy in Paraguay, and more precisely, on the introduction to our country of NTUST heat insulation solar glass. Professor Xin Huaiyong is our research advisor, and Janina Monjes and I, Eric Striving, will discuss the results of our learning and testing throughout this semester. On behalf of all students of the UPTP that worked on this project, I would like to briefly outline our aspirations. First of all, to learn about renewable energy through experimentation. Then, to expose Paraguay's potential for a more widespread adoption of solar power generation techniques. And finally, to hopefully inspire change in our country by ourselves someday. The application of photovoltaic modules on buildings. What makes heat insulation solar glass different? There is one key difference between traditional crystalline solar panels and solar glass, and that is transparency. Heat insulation solar glass is produced by applying a coating layer of semiconductor to the base glass instead of coating solid silicon ingots. This allows for various degrees of transparency the more silicon is cut, and gives solar glass the ability to serve different purposes, to be applied on buildings, in skylights or windows, rather than just on roofs, as traditional crystalline solar panels would be. So now I will walk you through the first of two tests my research team and I conducted. This one being focused on the application on skylights of 20% transparency heat insulation solar glass. The experiment consisted of, on a sunny day, measuring sun intensity and the corresponding current and voltage output of a 20% see-through test piece at regular 1-hour intervals. We tested from 8:30 a.m. to 4 p.m., covering the hours of effective sunlight to get an idea of how solar power generation changes throughout the day and in which direction should solar panels be aimed in our country. The experiment was set up as follows: setting the test piece at a 25-degree angle, which is the best slope for solar power generation in Paraguay, pointing northward and measuring current and voltage. This process was repeated for all 4 cardinal directions every hour. Here we have the highest measurements we obtained, which unsurprisingly came at 12 p.m. while pointing northward, when the sun is highest in the sky. We have here some examples of the experiment setup and the measurements we took. This table contains the data gathered throughout the day. The key takeaway here are the values of power output density, obtained by dividing power, which is current times voltage, by the area of the test piece. Plotting time of day and power output density gives the following graph, in which we can see that pointing north provides the highest power output for 20% transparency solar glass applied on skylights in Paraguay. Analyzing the results obtained from this test leads to the following conclusion. When installing photovoltaic modules in Paraguay, the best direction to point them in is north because they produce the highest average power output level. Now, as a personal conclusion to my learning of this subject, I will add that solar power calculation is easily done through specialized software that helps one pick the right parameters for installation. This can really be done by anyone, and I say it so as to encourage the adoption of renewable energy sources in our country. And finally, to leave you with the core message of this presentation, power generation, when done with the environment in mind, will put us in the right path to change our current climate situation. So I hope this proves to be a new option for Paraguayans to adopt. Thank you.
I'm Janina Monjes. I'm also a civil engineering student, and I'm going to explain a little bit about the differences between the 50% and 20% see-through heat insulation solar glass. To fully understand the difference between these types of solar glass, it's very important to mention about the production process. During this process, a piece of TCO glass receives a layer of semiconductor, in this case silicon, and right after that, by means of a laser inscriber, it receives consecutive line-shaped goods. The only difference between the 50% and the 20% see-through solar glass is that the 50% see-through receives a greater amount of goods, and for that reason it ends up allowing a greater amount of light to overpass the glass. The opposite happens with the 20% see-through solar glass. With respect to the application, the 50% see-through is mainly applied on windows because of its transparency levels, and the 20% see-through solar glass is mostly applied on skylights because it allows a minimum amount of light to overpass the glass and also helps to save resources that otherwise, with a normal roof, would have been invested on lighting systems. Here we can see the 50% see-through on windows and 20% see-through solar glass on skylights, as I mentioned before. And with respect to the testing process, I highlighted some points about the procedure. The first one is to set the solar glass at a proper slope. Because we are imitating the position of a window, we set it at 90 degrees from the horizontal, then we configure the multimeter to measure the current and the voltage. We also use a solar intensity meter to record the data of the sun intensity of that day. We measure the current voltage and sun intensity at each cardinal direction and repeat the whole procedure every 1 hour. Here are some pictures of the procedure. At the left-hand side, we can see the multimeter measuring the voltage and also the sun intensity meter right here. And at the right-hand side, the multimeter measuring the current. We ended up with this graph, which shows that the higher amount of power density was generated when the solar glass was facing north. Here, comparing the results of the 50% and the 20% see-through, we can observe that in all the cardinal directions, the 50% see-through shows lower levels of power generation. As a conclusion, I attach here a map to prove that our country receives a great amount of sunlight during the whole year, near 2,000 kilowatt-hour per square meter. So it's reasonable to think about the application of this kind of technology in our country, not only because it's a source of renewable energy, but because it offers other remarkable advantages such as versatility, because as I said before, it can be used for skylights, windows, also balcony barriers, and more places just by taking care of selecting a proper percentage of transparency. Also, it offers the reduction of climatization and lighting system expenses because of its insulation and transparency properties. And with respect to the aesthetics, it offers a clean, good-looking, and modern appearance. So it's not only a source of power generation, it's indeed a very convenient construction material. And that would be all. Thanks for your attention.
Team 2 are students there do the solar power efficiency test, and they will do the analysis of two kinds of glass.
Hello everyone, we are Team 2 and we are going to talk about the solar power efficiency of NTUST solar glass in Paraguay. I'm Daniela Bogarin and my classmate Camila Id were both students of civil engineer in the UPTP. So, the test was performed in Asunción, Paraguay in a sunny but cloudy day. In the morning around 10:30 a.m. We tested the 50% and the 20% see-through solar glass. We used a solar power meter to measure the sun intensity and a multimeter to measure a voltage and current. The solar glass have a transparency percentage, and in order to understand what makes them different between each other, we need to explain the making process. The semiconductor, thin silicon, is coated with many layers, to which is applied a laser sliver cutting process. The transparency is defined by the quantity of cuts were made on the glass. The more cut it has, the greater transparency, and for less transparency is fewer cuts. In the same way, this difference in the number of cuts is what defines the capability of solar power generation.
From the test, we gathered some data that we ordered in this table to express the performance of the 20% see-through solar glass. This solar glass has an area of 0.03 meters squared that we can see in the table, and also in the first column we can observe the sun intensity range that are from 100 to 1000. Then we can see the sun intensity measured value and the current values that are from 0.02 to 0.13. Also, we can see the voltage values that are from 17.07 to 19.58. These two values are those that affect the solar power generation of the glass. So next we can see the 50% see-through solar glass and that we also test and has the same area of the 20% see-through solar glass. Also has the same sun intensity range, and we can see now the current values that are from 0.01 to 0.08, and the voltage values are from 17.03 to 19.53. So if we compare, we can say that the 20% and the 50% see-through solar glass do not differ so much on the voltage, but differ on the current that they can produce. So to express the results, we display the gathered data in a graph of sun intensity versus solar power, and it's clear that the 20% see-through solar glass has higher solar power generation than the 50% see-through solar glass, and we can see that the 50% see-through solar glass is in blue color and the 20% see-through solar glass is in orange color. So that's all, and thank you very much for your attention.
Team 3 will do the heat insulation test for you, and they will tell you how the insulation efficiency of the solar glass.
Heat insulation efficiency of NTUST solar glass in Paraguay by Manuel Pasmore and Joaquin Maldonado. Team 3. The NTUST solar glass you have seen before has the property of being a high power generator and also a good heat insulator. But first, how exactly does solar heat work? The solar heat we all know is derived from solar energy. This energy travels from the sun as light particles called photons. These particles have different levels of energy and different wavelengths. However, all photons, especially low-energy infrared photons, can cause the objects to heat up due to an increase on the kinetic energy of the molecules. But how does the glass can use solar energy to produce solar power? Let's look at the heat insulation solar glass closer.
explain how this solar glass works, which was first developed in 2009, it actually was made out of a thin semiconductor film, and it was covered by a double glass layer of 4 millimeters at each side. It produces actually around 80 watts per square meter. By 2012, the second generation of the solar glass was developed, but this time it actually had 2 extra layers. It has this infrared reflection film with a gap of 6 millimeters at each side, and at the back another layer of glass of 6 millimeters. This time it produces 102 watts per square meter. So the test that you will see here now is the test that we performed with the help of Professor Young. We actually just measure the sun intensity on the front of the glass and at the back of the glass. And the result that we got for the first and second generation was the following ones. So actually for the first generation solar glass, on the first attempt we got an 84% of the heat efficiency obtained for it, while for the second generation on this first attempt was 96%. And for the second attempt, for the first generation, we got an 85%, while for the second generation was 96%. Thank you very much.
In addition, depending on the customer's need, a shading factor can be added, where the more shading in the glass is, the higher the energy produced by it, and also the greater the thermal insulation is. In comparison against a normal glass with a 50% see-through, it has only 40% heat insulation. While the HISG, the Professor Young invention, with a 50, 20, or even a 10% see-through solar glass, it can absorb up to 89, 91, and 90% of the heat respectively. In conclusion, we believe this technology is the future, and as Paraguay has more than 300 days of sunshine per year, it can be really productive to install them on a Paraguayan home, and not depending on the hydroelectrical power. This energy left can be sold to another market on the region with a more competitive price than the one we pay on our daily basis, considering it as a win-win for everybody.
Team 4 will do the simulation for you, the real application of solar glass on the building, and see the energy efficiency.
Hello everyone, our report is Energy Saving Efficiency of NTUST solar glass applied on buildings in Paraguay. My name is Xinling Tong. I'm a master student in NTUST. My research is application of laminated heat in solution solar glass and compare the effect between different combination of material in solar glass.
My name is Zhou Yuhong. I'm a master student in NTUST. My research is energy efficiency and indoor environment comparison between heat insulation solar glass and normal double glazing applied on glass facade.
We simulate this famous building in Asunción, use normal double glass and heat insulation solar glass double AG 10%, and we will compare the solar power generation, energy consumption, and energy efficiency between using two different materials in this building. First is solar power generation. This is our model. Glass facade size is 44 meter long, 27 meter wide, and 100 meter high. We use module in 4 facade. Total use 7,656 pieces. And the top, we use concrete material. This is the electrical value we input. Per module size is 1.4 meter long and 1.1 meter wide. Maximum power is 125 watts. We use PV solar to simulate, and we found that the building used HISGDA 10% can generate 620,000 kilowatts hour per year of solar power.
I will introduce energy consumption part. In energy consumption simulation, we have two facade types. One is HRSG double AG 10%. The other is normal double glass, and both of the top are concrete. These are optical and thermal properties of two different glass. U value is 2.15 and 2.674. SHGC is 0.143 and 0.706. We use Ecotech to simulate, and we found that the building use normal double glass need 3.8 million kilowatt-hour per year for cooling and heating. The building use HRSG only need 1.5 million kilowatt-hour per year. Finally, I will introduce energy efficiency part. This is energy efficiency in association. The yellow bar is power generation. We can see the building use HRSG can generate solar power and normal double glass cannot generate any power. The red bar is energy consumption. The insulation effect of HRSG is better than normal double glass. The green bar is traditional energy required. After power balance, HRSG only needs 940,000 kilowatt-hour per year from the grid. And the building use normal double glass still need 3.8 million kilowatt-hour per year. We can calculate that energy efficiency is 75%.
This is energy efficiency comparison. Left is Taipei. Energy efficiency is 69%. And right is Asuncion. Energy efficiency is 75%. And we can find that energy efficiency of Asuncion is better than Taipei. One of the reasons that in Asuncion will receive more sunshine and generate more solar power. Thank you for your listening.
Thank you for your listening. You can future contact with the website and you can look more information. Thank you very much.